guys, once again, welcome back to the DSA with DAX series. Today is day 42 of our series. We completed as far as 41 days of our series. Okay, and today we're gonna solve question number 1752 of Leetcode. It's basically check if array is sorted and rotated. Okay, and yesterday we solved question number 26 of Leetcode. It's basically remove duplicates from sorted array. Okay. So in which question we are finding that we have to remove duplicates from the sorted array and replace that elements in the nearest side of the like first element of that array and removing space left elements that doesn't matter. Okay. So if you can check out that yesterday's video if you does not watch yesterday's video, link in I button to yesterday's video. Okay. So first I'll explain the questions about when we move to the example part, then we discuss about possible approaches and later on we code that approaches and then we move to the time and space complexity for the code. So first I'll start with the question explanation. So let's start with question explanation. Given an array of nums, return true if the array was originally sorted in non-descending order. Okay, then rotated some number of position including zeros. Okay, so you have to return true if the array was originally sorted. When it was created, it is sorted. So you, and then after it is rotated in some number of position including zero. Okay, you have to return true if these conditions are followed. Otherwise, return you have to false. There may be duplicates in the original array. Okay, so that they're saying is in maybe original array there is duplicates elements are possible. Okay, not an array A rotated by X position result in any array B of the same length such that B of I equal to A of it's like a and some equation they're trying to saying that given to you is if the array is rotated it will becomes like the first array sorted is 1 2 3 4 5 or 6. Okay, it rotated from the three digits, so it will now become 4 5 again after 1 2 3 come to the end of that array. Okay, so 1 2 3 the rotated array. Okay, but the initial array is already sorted, so you know that yes this is the originally sorted, so you can return that true. Okay, so you have to work with the patterns. Okay, so this is the question. Now we'll move to the example part so you got clear better about the question. So the example one here is trying to say that nums array is 3 4 5 1 2. Okay, and it's true output, but you can see that original array is 1 2 3 4 5, and if the original array is sorted and you can take like x value equal to 3 positions afterward you try to do that begin, so you can got that your element in such a form 3 4 5 1 2. Okay, you will rotate with the x equal to 3. Okay, here you can see that example 2 is also given that 2 1 3 4. Okay, so it's not rotated because the x value anything you can take equal to x, it's not originally rotated because 2 1 3 4 is not a such form. If it's like that 2 3 4 and 1, so it will originally sorted by 1. Okay, so here is not possible, so they will return false. Here this question 1 2 3, it's basically x equal to 0 position. So this is the example. Look at the given condition like nums dot length is between 1 to 100 and the value which contains the nums array is also between 1 to 100. Okay, the length and the value both are in 1 to 100 range. Okay, so this is the question. I hope you got clear about the question. So now we move to the approaches part. Okay, so for these questions approaches part. Okay, so for this question our approaches are there like first we gonna with the simple count variable and add variable and will contain the length of the our array and count will storing that this is count or not. In first approach we move with the 0 to the end loop. Okay, and then in if condition we use our this given condition b of I is equal to like that. Okay, this condition, and if it's true we'll increase the count value, and if the count value is less than of our like 1 or equal to 1 we'll return it. Okay, so firstly, if the nums of I value is greater than our given value, okay, we take that index value and substitute in that, and the value which is come from this equation v of I like this equation is lesser than okay our nums of I. so we'll increase value, okay, and otherwise we'll skip each and everything, okay. So in cases we'll completed whole thing, okay, and we couldn't get value like count is equal to 2, so the our like this any array which is given in test cases are wrong, it's not, and if it's less than 1, yes, it's true, okay. So first approach we'll move with that, okay, and second approach we have is like use set of inbuilt functions like sort. We'll use firstly sort that array, afterward we'll join with the comma, and then after we use like double sort to identify pattern, and then after we use num string to comparison, and if it perfectly find a set of pair for that, so we'll directly return true or either false, okay. So first we'll move the first upward, so you got like level up right. So let's declare a let, okay, let count equal to 0, okay, and let n equal to nums dot length for let I equal to 0, I is less than n, I plus plus, and if our given nums of I is greater than, okay, is greater than nums of what is there given is plus 1, okay, and modulus n length, okay, okay, it's completed. So if it is greater, so we will increase count plus plus, and then after we'll move to the return part, and directly we return count if it's greater or equal to 1, it means, okay, okay, looks perfect things, okay, you can see that our answer is accepted. What we are here doing is this condition belongs to here, okay, we'll take on this entire condition same is here. So firstly if there will put the value in this given condition, okay, and if it's lesser than the our count of I value, we increase the count like nums of I is greater than our condition value, we'll increase count value, okay, and if count value is greater than 1, so it will return false because there is no sense of like possibilities. If there is 3, okay, x is equal to 3, okay, and again there is 4, afterward 5, okay, then 1, and then 2, okay. So it follows in sequence 3 4 5, then starting missing elements, okay, but if there is 3 5 4, okay, so it's not possible because if the array is sorted it contains only one let. First is like increasing 3 4 5 and 1 2 like that in same order, okay, not one bigger than smaller, not that possible, okay. So we'll submit for further lead code test cases to check this is perfectly correct or not. So you can see that our answer is accepted. All 112 test cases are passed. Okay, so this is the first approach for our question. We'll directly move with the for loop and conditions. So this is first. Now we'll move to the second approach based on inbuilt functions. So firstly, I'll remove this whole thing. Okay. In second approach, we'll use double sort for that like finding and pattern inside it. Okay. Value. Okay. So let's start second approach based on inbuilt functions. First we'll sort that our given array, okay. So I'll sort fonts, sorted variable to store that variable. Now we have to take entire nums array sorted, so I'll use split operator. Okay, I'll explain you how it's gonna work. Now sort between how sort, so sort have to like that A and B, okay, and if A dash B minus B, so and after that join each and every part we have to use join, but now it's twist, each and every time we'll simply directly join, but here we add a comma to identify the different numbers, okay, one pair has one count, okay. So now const use double sort. Okay, double sorted equal to sort plus comma plus again sorted. We will combining two times, okay, and then we ending of it. Now one number num string, okay, given questions comes in nums dot join given nums array will joining it with this sort, okay, and after we use return double sorted dot include. If it includes this given num of str, it will return true, and if not, it will return false, okay. So you might be wondering what I'm doing or how I'm doing, okay. So first sorted, okay, so first sorted contains, you can check here first example. So you try sorted first time, it will store elements like that 1 2 3 4 5, okay. First sorted is happening. Now double sorted, okay, it will store elements like, okay, again here plus, okay, then it will add here one more this, okay, and after that it will start with the one, okay. So now this double sorted looks equal to, it's twice of the our sorted array, exactly same as like this, okay. You can see that, okay. So the double sorted is look like that, okay, and num str is equal to num str is like that, our given 3 4 5 1 2, okay. So this is the num str. Now includes, try to find this pattern in our double sorted. So double sorted has like its saying starting from 3, so first not, second not, third, okay, 3, after that 4, okay, there is 4, after that 5, okay, there is 5, and 1 and 2, okay. So it will find that pattern inside that double sorted. Yes, it's successfully finded that pattern, okay. So this is perfect, this is correct, okay. This is has originally sorted, and afterwards it's rotated in some order of 3, okay. So like that you can check out that one more example. If there is 1 2 3, so here I'll remove 4 5, okay, I remove 4 5. So again you can see that there is 1 2 3. So here you got directly 1 2 3. So it's here like, yeah, it's originally sorted. So this is the how this double sorted system gonna work, okay. So I remove this whole thing, and now we'll run it to whether it is correct or not, okay. So you can see that this is answer is accepted, okay. Our double sort method gonna successfully work, and include function is also checking it with correctly. Now we'll submit, okay. So you can see that our all 112 cases are passed. So this is the perfect solution for that, okay. You can use this solution, okay. So now we'll discuss about the time and space complexity for these both approaches, okay. Okay, so now we'll discuss about the time and space complexity for that, okay. So our first approach, where we move with the two extra variables and with one for loop. So for that approach, our space complexity is order of n. We using only two variables. First is count to store count, and another variable is n to store the length of the nums array, okay. So for that approach, space complexity is order of one, and time complexity is order of n. We using one for loop from starting of the our nums array to the ending of the nums array. So it will becomes order of n, okay. So time complexity is order of n, and space complexity is order of one, okay. So for that approach is like that, okay. Now we'll move to the second approach, okay, where we using multiple things, okay. Okay. So first thing is our like space complexity becomes order of n, and we using entirely new sorted array inside sorted variable, okay. So it will becomes order of n, okay, and the space complexity is order of, and now time complexity is for sorting using dot sort function is n log n, okay, and afterward join is like order of n, okay. Time complexity for sort is order of n log n, and for like join inbuilt function is order of n. So the our final time complexity for this, okay, is become order of n log n, and space complexity is order of n. You might be think this is greater, but if you have to go with the inbuilt function, you have to like de- deal with this greater time complexity and its space complexity. So okay, now we'll move to the tomorrow's question. So firstly I'll open it. Okay, so it's basically count the number of consistent strings. Okay, so you have to count the number of consistent strings in the given uh, like allowed word string. So you are given a string allowed, okay, consists of distinct characters and the array of strings, okay, of words, okay. A string is consistent if all characters is in the string appears in the allowed. Okay, return the number of consistent strings in the arrays of word. Okay, so okay, so if the allowed consists of like word with like x y z, and the word array contain an string of like a third index which contains x y or y z, okay, which all is belongs to the allowed word. So you have to return that the output is yes, it's allowed. You have to count that. Okay, so now firstly we'll see the example word. Allowed is AB and words contains AD, BD, AAB and BAB. Okay, so output is 2. There is two variable which is perfectly allowed. Okay, like AAB and BAA are consistent since they are only contain characters A and B. Okay, so I hope you got clear about this. Now we'll see the condition. The words dot length is between 1 to 10 to the power 4. The array of words length is 1 to 10 to the power 4, and the string allowed is between 1 to 26. It may be contains each and every characters of our alphabets. Okay, words dot I dot length is between each and every words element length is between 1 to 10, and the character in allowed are distinct. Okay, the characters should be added inside of allowed is all are different unique, and words of I and allowed contains only lowercase English letters. It will contains only lowercase English letters, so you does not have to worry about that the special characters and like that. So you have to try this question. After completing, you have to post it on LinkedIn and Twitter. Mention me. And don't worry if you don't solve this question. We're gonna solve this question in tomorrow's video. You can check out that video and understand questions. Okay. And if it does not started yet DSA with the series, you can start link in I button from day one where I'll explain each and everything about series. Okay. So you can check out that video and start DSA series from that. Okay. And one thing, you have to stay consistent to master DSM. Okay. And once again, thank you for the watching video. Meet on tomorrow's video.